In the shrouded depths of caves in China, a new viral threat has been discovered lurking within the wings of bats. Scientists have identified a novel coronavirus strain designated HKU5CoV2. This discovery, published in the esteemed scientific journal, has sent ripples of concern throughout the global health community. HKU5CoV2 shares a worrying degree of genetic similarity with the infamous SARS-CoV-2, the virus responsible for the devastating COVID-19 pandemic that brought the world to a standstill. This new virus belongs to the same viral family, Coronaviridae, and even shares the same subgenus, Myrbecovirus, as both SARS-CoV-2 and MERS-CoV, the virus responsible for the Middle East Respiratory Syndrome, MERS, outbreak in 2012. The genetic kinship between these viruses is a stark reminder of the interconnectedness of all living things and the potential for viruses to cross species barriers, threatening human health. While HKU5CoV2 has not yet been found to infect humans, its discovery serves as a timely reminder of the ever-present threat of zoonotic diseases. The identification of HKU5CoV2 underscores the importance of ongoing surveillance of wildlife, particularly bats, for novel coronaviruses. Bats harbor a vast diversity of coronaviruses, many of which have the potential to spill over into other animal species, including humans. Understanding the genetic makeup, prevalence, and distribution of these bat viruses is crucial for assessing and mitigating the risk of future pandemics. The emergence of zoonotic diseases, those that originate in animals and jump to humans, is a complex interplay of ecological, biological, and human behavioral factors. The process by which a virus successfully makes the leap from animals to humans, known as zoonotic spillover, is a multi-step process often requiring a perfect storm of conditions. Firstly, close proximity between humans and wildlife, particularly in settings like live animal markets or areas undergoing deforestation, increases the likelihood of viral transmission. Secondly, the virus must undergo genetic mutations that allow it to effectively bind to and infect human cells. Just as a key must fit a specific lock, viruses rely on specialized proteins on their surface to latch onto receptors on the surface of host cells. These receptors act as gateways, allowing the virus to enter and hijack the cellular machinery of the host. For a virus to successfully infect a new host species, it must acquire mutations that enable its surface proteins to recognize and bind to the receptors of the new host. Thirdly, the virus must be able to replicate efficiently within human cells and spread from person to person in a sustained manner. This sustained human-to-human transmission is a critical determinant of whether a novel virus will cause isolated cases or escalate into a full-blown epidemic or pandemic. The ease with which a virus spreads between humans depends on factors such as its mode of transmission, the infectious dose required, and the susceptibility of the human population. The emergence of HKU5CoV2 is not an isolated incident, but rather the latest chapter in a long and cautionary tale of zoonotic diseases. History is replete with examples of viruses that have made the jump from animals to humans, often with devastating consequences. The 2003 outbreak of severe acute respiratory syndrome, SARS, caused by the SARS-CoV virus, serves as a stark reminder of the pandemic potential of bat coronaviruses. The SARS virus is believed to have originated in bats, spread to civet cats in live animal markets, and ultimately infected humans. Similarly, the Middle East Respiratory Syndrome, MERS, outbreak in 2012 caused by the MERS-CoV virus, highlighted the role of camels as intermediate hosts in the transmission of bat coronaviruses to humans. And of course, the COVID-19 pandemic, caused by the SARS-CoV-2 virus, has left an indelible mark on human history, underscoring the profound global impact of zoonotic diseases. These past pandemics underscore the critical importance of understanding the factors that contribute to zoonotic spillover and the need for proactive measures to prevent future outbreaks. While HKU5CoV2 has not yet been found to infect humans, its genetic similarities to SARS-CoV-2 and its ability to bind to human ACE2 receptors in laboratory settings raise concerns about its pandemic potential. The ACE2 receptor, found on the surface of cells in the human respiratory system, acts as a gateway for both SARS-CoV-2 and HKU5CoV2. allowing these viruses to enter and infect human cells. However, it is important to note that the ability to bind to ACE2 receptors alone does not guarantee that HKU5-CoV2 will cause a pandemic. For HKU5-CoV2 to pose a significant threat to human health, it would need to overcome several hurdles. Firstly, it would need to acquire mutations that enhance its ability to bind to human ACE2 receptors and replicate efficiently within human cells. Secondly, it would need to evolve mechanisms to evade the human immune system, which has been primed by prior exposure to coronaviruses, including those responsible for the common cold. Thirdly, it would need to find a suitable animal host that facilitates its transmission to humans or evolve the ability to spread directly between humans. While the emergence of HKU5-CoV2 is a cause for concern and warrants close monitoring, it is not yet a cause for panic. Scientists are actively studying the virus to better understand its characteristics, assess its pandemic potential, and develop strategies to mitigate its risk. Section 5. Preventing the next pandemic, a multifaceted approach. The emergence of novel coronaviruses like HKU5-CoV2 serves as a stark reminder of the urgent need for proactive measures to prevent future pandemics. A comprehensive approach is required, one that addresses the root causes of zoonotic spillover and strengthens our global capacity to detect, respond to, and control emerging infectious diseases. This multifaceted approach should encompass a range of strategies, including enhanced global surveillance of wildlife, stricter regulation of the wildlife trade, accelerated vaccine research and development, and strengthened healthcare systems worldwide. By investing in these critical areas, we can reduce the risk of future pandemics and protect the health and well-being of people around the globe. Preventing pandemics is not merely a scientific endeavor, it is a shared responsibility that demands collaboration, innovation, and a steadfast commitment to safeguarding global health. Section 6. Global Surveillance, our early warning system. Enhancing global surveillance of wildlife, particularly bats and other animals known to harbor coronaviruses, is paramount to detecting novel viruses with pandemic potential before they have a chance to spread widely. This surveillance involves collecting samples from wildlife, testing them for known and unknown viruses, and characterizing the genetic makeup of any novel viruses detected. By establishing a robust global surveillance network, we can create an early warning system that alerts us to potential threats and allows us to respond rapidly to outbreaks before they escalate into global crises. This surveillance effort requires international collaboration, data sharing, and adequate funding for research institutions and public health agencies engaged in wildlife monitoring. Investing in global surveillance is akin to investing in an insurance policy for global health, providing us with the information and tools we need to stay one step ahead of emerging infectious diseases. Section 7. Taming the wildlife trade. The unregulated wildlife trade, often driven by demand for exotic pets, traditional medicines, and bushmeat, poses a significant risk for zoonotic spillover. Live animal markets, in particular, create crowded and unsanitary conditions where viruses can easily jump from animals to humans. Stricter regulation and, where necessary, bans on the trade of high-risk wildlife species are essential for reducing the risk of future pandemics. This includes strengthening enforcement efforts to combat illegal wildlife trafficking and promoting sustainable alternatives to wildlife products. By addressing the root causes of the wildlife trade, we can disrupt the pathways through which viruses move from animals to humans, protecting both human and animal health. Section 8. Vaccines and therapeutics, our first line of defense. Investing in research and development of vaccines and therapeutics targeting known viral families with pandemic potential, such as coronaviruses, is crucial for our ability to respond rapidly and effectively to outbreaks. The development of mRNA vaccine technology, as demonstrated by its success in combating the COVID-19 pandemic, represents a major breakthrough in vaccinology. Continued investment in this area could lead to the development of universal coronavirus vaccines capable of providing broad protection against a range of coronaviruses, including those not yet discovered. Similarly, the development of antiviral drugs that target conserved viral proteins, essential for viral replication, could provide valuable tools for treating infections and reducing the severity of disease. Section 9, a call for global cooperation and vigilance. Preventing future pandemics is not a task for any single nation, but a shared responsibility that demands global cooperation, transparency, and a commitment to evidence-based decision-making. Strengthening global health governance through organizations like the World Health Organization is essential for coordinating international efforts to detect, respond to, and control outbreaks. This includes providing technical assistance and financial support to countries with weaker health systems, promoting data sharing and collaboration among scientists and public health experts worldwide, and ensuring equitable access to vaccines, therapeutics, and diagnostic tools. The COVID-19 pandemic has served as a stark reminder of our interconnectedness and the devastating consequences of global health inequities. We must learn from this experience and work together to build a more resilient and equitable global health architecture capable of meeting the challenges of the 21st century. The spectre of infectious diseases is a constant companion to humanity. However, through vigilance, proactive measures, and unwavering global cooperation, we can mitigate the risks posed by these microscopic adversaries and safeguard the health and well-being of generations to come.